This is Unit 9, Lesson 3, and we're going to focus on number 11. So I see secant. We don't pronounce it sec. The secant, y equals the secant of x. And I recognize that secant is just reciprocal of cosine. So I'm going to start at 0, and I'm going to identify what is the value at the cosine of 0. So here's 0. And the cosine is the first value, so it's 1. Now, if I take the reciprocal of 1, I'm still left with 1. So at this value, I am able to go up to 1. Okay, now, before I go any further, let's figure out what is the period and what is the x scale for this particular function. So because secant is reciprocal of cosine, I'm going to take 2 pi, and I'm going to divide it by the value in front of the x, which is 1. So I'm left with 2 pi. And then the x scale is I take that value of 2 pi and I divide it by 4 to end up with pi over 2. All right, so each one of these steps or lengths along the horizontal axis is a distance of pi over 2. So I'm started here, and now I'm going to go a distance of pi over 2, which is equivalent, by the way, to 90 degrees for those who like to do in terms of degrees. So here I am. I'm up here. I'm going to focus in on the cosine, which is 0. Now, if I take 0, which is the same as 0 over 1, and I take the reciprocal, I'm left with 1 over 0. And 1 over 0 is not a value. That's why it's undefined. We can never have 0 in the bottom or in the denominator. Okay, I'm going to keep going here. So I'm at 90. Now, I know that an entire cycle, just like we did in number 10, an entire cycle is 2 pi. So I've gone up here. Now I'm going to go another distance of pi over 2. That's another 90 degrees. So if you want to think of this as a compass, we're right now at the west. The cosine is the first number, which is -1. And if I take -1 and I take the reciprocal and I evaluate it, I'm left with -1. So over here, I'm going to go down to -1. Okay. Now next, after this, I want to shoot down here to the south side of my compass, known as 270 degrees or 3 pi over 2. The cosine is 0, and 0 over 1, when I take the reciprocal, results in another undefined value, or a vertical asymptote. So I've done 4 steps. 1, 2, 3, 1, 2, 3. Oh, I gotta go one more here. So I'm gonna go one more up all the way up here. My cosine is 1. And if I take 1, I take the reciprocal, I'm left with 1. Now, just like the previous one, I need to know really what does this look like. So I'm gonna start, and I think I'm gonna go to the left. So I'm gonna reverse this here. Remember, I went around this way and I finished. Well, to go to the left, I'm just gonna reverse it. So I was here. Let's reverse it down 1. The cosine, let me bring this back up here. The cosine is 0. So I'm at this point right here. The cosine is 0. And if I take the reciprocal of 0 over 1, I'm left with an undefined value. Now, why did I do that? Because now I should be able to have a better view of this. Remember, we did the same thing over here. So I need to know, does this go up? Does it go down? Does it snake through at that point? What happens? So I'm going to go to the cosines, and I'm going to go, this is 0. I'm going to go between 0 and pi over 2, and I'm going to choose a value that I can easily identify the reciprocal to for cosines. Why cosine? Because secant is equal to the reciprocal of cosine. So let's look between 0 and pi over 2. Okay, so I'm looking here, and I can easily see it once again that 1/2 is going to be the easiest cosine value to take the reciprocal of. When I take the reciprocal, I get 2 over 1 or 2. Now that's just before I get to 90 degrees or pi over 2. So just before I get to the very first endpoint, I'm going to have an output of 2. So just before I get to the very first step or output, I have an output of 2. I'm going to guess, based on what we did in number 10, the same thing's going to happen over here. So I'm going to guess that if I go reverse, so again, here's the origin, let's reverse it. So if I go down to quadrant number 4, and I look at the cosine's, the easiest value to take the reciprocal of is 1 over 2. Again, it results in 2 over 1 or 2. So just before I get to reverse, just before I get to a negative 90 degrees or negative pi over 2, I'll have an output of positive 2. So just before I get to this reverse step, I get an output of 2. And I'll do the same thing here. So this is going to be, if I want to think of in terms of radians, this is pi over 2. This is 1 pi or 180. So let's look in between pi over 2 and 1 pi. Or if you want to think of it in terms of degrees, let's look between 90 degrees and 180. So we're looking here in quadrant 2. I'm focused in on the cosines, and the easiest one is going to be -1 over 2. The reciprocal is going to be -2. So just after the first step, I have an output of -2. Just after the first step, I have an output of -2. We got to do one more. So now we're going to go, let's see, step 1, 2, in between step 2 and 3. So I got it here. This is pi over 2. This is pi. So in between pi and 3 pi over 2. So that's going to be down here in quadrant number 3. I focus in on the cosines, the first number, -1/2. The reciprocal is -2. It's just before I get to the next step. -2 just before I get to the next step. Okay, so I just need to repeat this pattern. I'm going to press pause, and I'm going to make the vertical asymptotes every other line. All right, I've done that. Now I'm going to go back, and so this is going to go up, and this is going to go down. And we're going to go up on the right, down and up, down and up. Now, what is this length? 1, 2, 3, 4, 5, 6, 7, 8. So I went 8 steps to the left, 8 steps to the right. Each step is a length of pi over 2. So I have 4 pi to the right and -4 pi to the left. Let's take a look at number 12. Okay, let's look at number 12. Now, number 12 is a cotangent function. Remember, cotangent is going to be the reciprocal of tangent. Also remember that when we're figuring out the period length of tangent, we're not going to use 2 pi, we're going to use pi. So I'm taking the value in front of the x, which is a 1, and taking pi divided by that number. That means the period length or period for number 12 is simply going to be pi. I divide it by 4 just like I do in number 10 and number 11. And I have every step is pi over 4. Now, I already previously did this in a video where I went through and did a lot of the easy ones. So I took the tangent, which is sine divided by cosine. I took the tangent at 0, if you want to think of it in terms of degrees, 45, 90, 135, 180, and so on. So every 45 degrees, I've already figured out the tangent. And that ended up being helpful because here I'm going to take steps of pi over 4, which is equivalent to 45 degrees. So in the unit circle, when I'm actually going to do this, I'm going to go 45, take the reciprocal, 45, take the reciprocal, 45, take the reciprocal, and so on. All right, let's get started. So I'm starting here at 0. Now, at 0, remember that tangent can be thought of it as sine over cosine. So if tangent is sine over cosine, then cotangent is the reciprocal. It is cosine over sine. That will be helpful. Okay, so when I look here and I go cosine divided by sine, excuse me, for the cotangent, that's what I'm graphing. Oh, I'm allergic. I'm allergic to something here right now. Cosine divided by sine, 1 over 0, we can't do it. It's impossible. So at 0, I have a vertical asymptote. Now let's move 90 degrees upward, or a distance of pi over 4. And again, when I take cosine divided by sine, they're the same thing. So I take the same thing, I just get an answer of 1. Just like the reciprocal of 1 is just simply 1. So go over and go up 1. Let's move another 45 degrees. When I take cosine divided by sine, 0 divided by 1 is 0. Let's move another 45 degrees. When I take the cosine divided by the sine, they're the same values, but they're different signs. So I end up with an answer of -1. When you take the exact same value divided by itself, you get 1. How you determine the signs is just based on what symbol is in front of each. So a negative divided by a positive is a negative. So I'm going to go -1. Okay? And now here, cosine divided by sine, -1 divided by 0. is not 0, it's undefined. Now here's the great news. I just did 1/4. Now I'm up to pi over 2, 3 pi over 2, and it ended at 1 pi. So I just did one cycle, a total of one cycle. One cycle is a distance of pi. So from here to here is a distance of 1 pi, or 4 pi over 4, 6 pi over 6. It all is going to simplify to 1 pi. So I've already done one cycle. I can see what this looks like. And now I just need to repeat it. So I'm going to go 4 to the right. 1, 2, 3, 4. 4 over here. And go back and put in the exact same thing. So in the middle, we're at 0. We're up 1 and down 1. Oops. All right. Now, what is going to be the x facts of the x bit above? So I need to count 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 8 to the right. Each of these distances is a distance of pi over 4. 8 pi over 4 reduces to 2 pi to the right and negative 2 pi to the left. Let's take a look at number 13. Okay, so if you've caught on to this as we've graphed the other graphs, when we look at this, I'm really focusing on what does the secant look like. So I already know the secant is going to look like this. There is no vertical shift. There is a stretch, which means it's going to rise faster and fall faster. And I can see that the period length and x scale will be impacted by the value in front. But it's the same basic shape. So I'm going to start first by identifying what is the period length. So because cosecant is the reciprocal of sine, I'm going to take 2 pi and divide by the value in front. So 2 pi over 3, that is the length of one cycle. Now let's come back here and even talk about what was a cycle. So up here, a cycle was right here. This is one cycle. So for this problem in number 4, this cycle is a length of 2 pi over 3. Now, what is each one of these steps? Well, I'm going to take this value and I'm going to divide it by 4. When you divide by 4, you're going to multiply by the reciprocal to get 2 pi over 12. 2 pi over 12 is equivalent to 1 pi over 6. So each of these steps is 1 pi over 6. Now, everything else is exactly the same. So I can look back up here and I'm going to press pause to save you time. And I'm going to make the vertical asymptotes. Now what we need to look at is we need to look at how are we able to actually graph this? Like what did we do here in order to graph this? Remember that cosecant is the reciprocal. Cosecant is a reciprocal of sine. And so when I went back here and I looked at this, I started here at 0. Let me go back here. I started here at 0, and then at 0, the reciprocal of 0 over 1 is 1 over 0, and that's how I got this vertical line. Now, I went over a distance of pi over 2, which is right here. I went over a distance of pi over 2. Let me move this down so everybody can see who's watching. And I identified the sine value. Well, the sine value was 1. And if I took the reciprocal of 1, I still got 1. Now, what's the difference here is that still holds true. So I'm going to go over 1, but instead of going up 1, because that's the output is 1, that's how I knew to graph this. The output was 1 when I took the reciprocal, but now I need to take that times the value out front because it's being stretched. So instead of going over 1 and up 1, 1 times 2 is 2. I'm going to go up 2. And the same thing can be said. I went over 1, 2, 3 steps and down 1, 1, 2, 3, but now instead of going down 1, negative 1 times 2 is negative 2. And over here, I went just before each one of these, I went slightly to the right and to the left of my vertical lines, and I went up 2. Well, 2 times 2 is 4. That's how it increases or it stretches faster. So just before the lines, instead of going up 2, I'm going to take that 2 times 2 to get 4. And the same thing down here. I'm going to go down 4 and down 4. So it rises and falls faster. And I'll just repeat that over here. I'm going to press pause and I'll finish this so you don't have to watch. All right, so I've gone through and I've graphed number 13. Let's figure out now what is the x minimum and the x maximum. The length of each one of these steps along the horizontal axis is a distance of 1 pi over 6. So I have 1 pi over 6, and I have 8, 2, 4, 6, 8. So 8 pi over 6. Now 8 pi over 6 reduces to 4 pi over 3. So this is 4 pi over 3 to the right and negative 4 pi over 3 to the left. I know these are somewhat painstaking when it comes to the time it takes to graph this. So I'm going to focus on the secant. It means I'm going to look up to number 11 and use number 11 as a way to kind of guide me. So just like number 13, what I see is the value in front of the x has changed. That's going to impact my period length and x scale compared to the parent function of the secant. And as a reminder, secant is reciprocal of cosine. So let's go ahead first and let's figure out what is that period length. I'm going to take 2 pi. I'm going to divide it by 2 to end up with a period length of 1 pi. Period length of 1 pi. Then I'm going to divide that value by 4 to get 1 pi over 4. All right. The value out front is going to impact it because it's going to stretch. So when I look back up here at secant, instead of going up 1, this is output of 1 times 3, it means I'm going to go up 3. Instead of going up 2 to the left and right, 2 times 3 is 6. So I'm going to do this very first one. I can see that from the origin to the left and right, I have these vertical asymptotes. I will do that. And instead of having an output where I go up 1 times 3 is 3, I'm going to go up 3. And we normally go up 2 to the left and right just before I hit those vertical asymptotes, but 2 times 3 is 6. 1, 2, 3, 4, 5, 6. So somewhere up here and somewhere up here. Okay, and I'm just going to follow this basic pattern. I'm going to press pause. The only difference is instead of going down 1 now, I'm going to go down 3 because 1 times 3 is 3. All right, so I'm going to go here down 3 instead of down 1. And up here, go up 3 and down. Starting at 3, we want to get that one vision. Over here, down 3 and up 3. Down 3 and up. Okay, now this distance I've already counted enough times. This is 8 steps to the right from the origin, so 8 times. Each step has a length for this particular function on the horizontal axis of pi over 4. So I get 8 pi over 4, which is equivalent to 2 pi to the right and negative 2 pi to the left. Let's take a look at number 15. I'm going to rewrite number 15. Y equals 2 times the cotangent of 1/3 x. Now, when I do number 15, I'm going to relate back to this graph. So because this is a 2, I know what we're still going to have. It's a positive 2. We're still going to have the same basic shape, but it's going to drop and rise faster. For instance, instead of going over 1 and down 1, it's going to go over 1 and down 2. The output is 1. 1 times 2 is 2. And the output is positive. Sorry, it was negative 1. The output is positive 1. 1 times 2 is 2. So it'd be going up 2 here and down 2 here. Everything else will basically look the same. A cycle length will change because we have a 1/3 in front, and that will impact also the x scale. Let's go ahead and figure out the period length. When we're working with tangent or the reciprocal cotangent, I have pi divided by whatever value is in front of the x, which is a 1/3. So I'm going to divide by 1/3, which means I'm going to multiply by the reciprocal 3 over 1, and I end up with 3 pi over 1, which is equivalent to 3 pi. Now I'm going to divide that by 4 to get 3 pi over 4. So each one of these steps is simply 3 pi over 4. Everything else will look the same again, other than it's stretching and stretching faster and declining faster. So I'm going to go back to this and press pause here and make my vertical asymptotes every 4 to the left and the right of. Right, so I've done that, and Again, if I come back up here, I can see that I'm going to go to the right, and we're at 0. And now 1 to the right would be up 1, but we're going to multiply that by 2. So I'm going to go up 2. This would generally be down 1. I'm going to multiply it by 2. It just rises and falls at a faster pace. I can hear my kids arguing in the other room, so I'm going to have to press pause in just a second here. Go check this out. We're going 8 steps to the right. 8 times 3 pi over 4 would be 24 over 4, which is equivalent to 6 pi to the right and negative 6 pi to the left. Oh, I'm getting tired of these. I wonder if you're also feeling the same way. All right, so let me rewrite this as y equals negative 1 secant of pi x. So let's just take an idea here. I know that I'm going to relate this back to the original secant, which is in number 11. So this same basic shape. But now when I multiply by the negative 1 out front, what it's going to do is it's going to reflect across this horizontal asymptote. So instead of going up, it's going to go down. Instead of going down, it's going to go up. Also, we will have a difference in the length of the period and then, in fact, the x scale. So let's figure out the period length. Secant is reciprocal of cosine. So I'm taking 2 pi and dividing by whatever's in front of the x, which is a pi. This is going to reduce down to just a period length of 2. Now I'm going to take 2 and divide it by 4, and I get reduced down to 1/2. So each distance here, or each step on this horizontal axis, is going to be a distance of 1/2. Now I'm able to copy this general idea for secants. So from the origin to the left and right, I'm going to start making vertical asymptotes. Now, small mistake here. So I changed it to red. I want you to forget about this when I was counting and my eyes just slipped here. Just 1 to the right and 1 to the left. So I've made my vertical asymptotes that are going to align with this parent function, y equals the secant. Now what's different is instead of going at the origin, instead of going up 1, that output of 1 is going to be multiplied by the negative 1 in front. So I'm going to go down 1. And then we have the exact same thing. We're going to go down here. And over here, I'd go up 1 and down 1. It's just going to be mimic that pattern. All right, now let's look at the distance. There's 8 here. 8 times each step being 1/2 would be 8 over 2, which is 4 to the right, and negative 4 to the left. Let's take a look at number 17. Hold with me here. Okay, much like number 17. Oh, all right, they're just having fun here. I thought they were fighting. Okay, so when I look at cosecant, I'm going to revert back to number 10. So if you have your paper done, I'm going to look back to number 10. Now the number in front of the x is different than 1, so my period length will change, and so will my x scale. I'm going to figure that out right now. Cosecant is reciprocal. Cosecant is reciprocal of sine. So I'll take 2 pi and divide by this 2/3, which means I'm really going to multiply by the reciprocal to get 6 pi over 2. 6 pi over 2 is equivalent to 3 pi. It's equivalent to 3 pi. Then I'll divide that by 4, and that means that every step here along the horizontal axis is a distance of 3 pi over 4. All right, next. Now after that, I've taken care of this part. After that, the negative sign means, if I come back up here to the parent function, it means that instead of going up here, I'm going to go down. Instead of going down, I'm going to go up. In addition to that, 2 means that it's going to be stretched by a factor of 2. So I look up here, I examine the parent function for cosecant, because this is a cosecant function in number 17, and I can see that every 2, as I move to the right, as I move to the left, I have a vertical asymptote. So let me put those in place next. All right, so I've taken care of that, and now remember, I've taken care of that negative sign. Now I need to amplify everything by 2. So, sorry, I've not taken care of the negative sign. I need to keep that into account. So if I move over 1 and go up 1, the output was 1 for the parent function of cosecant. So the output was 1 as a positive 1, but instead of going over 1 and up 1, 1 times negative 2 is negative 2. It's going to go down. The same thing here. I went over 3 and down 1, so the output was -1, but -1 times -2 is a +2. And so I'm able just to continue this pattern here. Okay, so we have 8 to the right. 8 times 3 pi over 4 would be 25 pi over 4, which reduces to 6 pi to the right and -6 pi to the left. Let's take a look now at number 9. All right, so I'm going to revert back to problem number 12. Problem number 12 is going to be the parent function of cotangent. Let's start by remembering that tangents and cotangents, to figure out the period length, I'm going to take pi and divide it by the value in front, which is 3 pi. These are going to reduce down to 1, and I end up with 1/3. 1/3 is the period length. Now I'm going to take that 1/3 and divide it by 4, which means I'm going to multiply by 1/4 to get 1/12. Each step along the horizontal axis is a distance of 1/12. So I've taken care of this. Now the negative sign means we're going to reflect across the x-axis, and 3 means we're going to stretch it vertically by a factor of 3. So what does that mean? It means here, instead of going over 1 and down, instead of going over 2, which will remain the same, so I could actually put that into place right now. I go over 2, and I should actually start by identifying where are the 5 different vertical asymptotes that we can see on this function. Right, I think it definitely will be easier to see now. So I started here, but now, so the output 0 times -3 doesn't change anything, and that's why this remains at 0. Again, I'm taking -3 times the output. But if I go over 1 from the origin, the output was 1. 1 times -3 is -3. And the output 3 steps, 1, 2, 3, the output was -1. -1 on the third step, -1 times -3 is a +3. Okay, ooh. So that's what we're going to do right now with these others. We're going to come in and go down. Come in and go down. Come in and go down. Okay, we have 8 steps to the right. 8 times each one of these steps is a length of 1/12. I get 8/12, which reduces to 2/3. 2/3 to the right and -2/3 to the left. Let's look at our final one. All right, now what's different about this compared to any other problem I have on this page is we do have a vertical shift. So everything's going to shift up 1. And now I'm going to get rid of that. And I'm going to rewrite this as y equals 2 times the cosine of 3/2 x. Let's next identify what is the length of the period. Now, since cosecant is reciprocal of sine, I'm going to take 2 pi and divide by whatever's in front of the x, which is 3/2. So 2 pi divided by 3/2, which means I'm going to multiply times the reciprocal, and I end up with 4 pi over 3. 4 pi over 3. I'm going to take 4 pi over 3 and I'm going to divide it by 4, which means I multiply it by the reciprocal, and I get 4 pi over 12, which reduces to pi over 3. So I've taken care of all of this. I've taken care of this. Now I need to look up to the parent function of the cosecant, which is number 10, and I just need to stretch everything by a factor of 2. So this is what it looked like. I'm going to start by going through and making all of these vertical asymptotes. So let me do that first. I've graphed all the vertical asymptotes. I've taken care of that. And remember here, we need to multiply the outputs by a factor of 2, So I come back up here and I go, okay, the first step went up 1. An output of 1 times 2 would be 2. So from here, because this is my new origin, right? This is my new origin. So I went over 1 and I'm going to go up 2. And we can see that I went just slightly to the left and to the right, so left and right of these vertical asymptotes, and I went up 4. Well, that output of, and I went up 2. The output was 2. but 2 times 2 is 4. So I'm going to go from here. This is my new origin. I'm going to go up 4 here and 4 here. It just helps us to draw a more accurate sketch of this. Okay, now the same thing here. Next will be down, but instead of going down 1, I will be going down 2. So right here, going down 2. So this is my new midline, if you want to think of it. So I'm going to go down 2, and then 4 will be right here and right here. I'm just copying this all over again, up and down, down, and up, and up. All right, there we go. Now this is a distance of 8. 8 times pi over 3 is still 8 pi over 3 to the right, and negative 8 pi over 3 to the left.